Hello, let us begin our study of time series analysis as a part of the data analytics course. As you know, we have talked about three kinds of data analytics: descriptive, predictive, and prescriptive. Time series analysis is mostly about doing predictive analytics, that is, predicting the future value of a variable or forecasting a certain amount along a particular dimension. So let us do this in about 7 parts. In the first parts, I will introduce time series. We will compare this to another technique that could be used for predictive analytics, such as regression. So when to use regression, when to use time series methods, and then we will look at a variety of examples of time series data. In the second part, we will actually start looking at the nature of time series data and the various components of the data that we look for, things like trend, seasonality, and what are the various operations that we can perform on time series data. In the third part, we will go back to the R language and do a variety of time series operations using R and R Studio. In particular, we will look at things like how to detrend a time series data. All of these will become clear as we go through the various topics in time series analysis. In the fourth part, we will look at one of the major techniques for doing time series analysis, which is smoothing, and the idea of a moving average will be developed into the particular method known as the Holt-Winters method, and we will see how we can use that to do forecasting very effectively using time series modeling. In the fifth part, we switch gears and get to the second major method for doing time series analysis based on the idea of autocorrelation, and we will develop the models for doing time series analysis, things called ARMA and ARIMA and so on. And in the sixth part, we will look at ARIMA in greater detail, and we will actually carry out ARIMA modeling on example data sets using packages in the R language. And in the last part, we will look at some advanced techniques in time series analysis, how to do analysis in the frequency domain. For example, if you have rainfall data and so on, how we can actually try and predict monsoon rainfall and why it is so difficult to do that. Some of those things we will look at in the final part of this module on time series analysis in the data analytics course. So let's begin with the first part, namely time series data. So when we are talking about time series analysis, we are essentially looking at time as a dimension. So we have historical data, and based on that historical data, we are trying to predict the future, or we are trying to forecast, as we say. So normally the term forecast is used for weather. You might have heard of weather prediction, weather forecast, and so on. But it can be applied to any variable, any quantity that changes over time. So essentially in time series analysis, we are dealing with a data set that has two variables, and one of the variables is time. So in other words, the x-axis is time and the y-axis can be any other thing. For example, the price of a commodity, or the stock price, or the temperature on a particular day, the number of passengers traveling in a particular airline. Any of those can form the variable whose value we are going to predict for the future, right? So why is this important, and how is this different from some other techniques like regression? So why can't I simply treat this as a regression problem, right? I'm sure you have already studied regression and correlation. So why can't I simply do regression modeling, and why do I need a special set of methods called time series analysis methods, simply because one of the variables is time, right? So why do we need this? So let's look at a variety of example data to try and make sense out of this. So we collected some data. This is the price of petrol per liter in Bangalore city. So this keeps varying over time. So this data set shows its values for about 5 years, right? So how the price of petrol has changed over time. Now, if you look at this, right? So x-axis is time. It starts with 2015 and goes on, and it has gone here all the way, a little into the future as well, up to December 2020. Now, the price of petrol has varied, as you can see, probably from somewhere around in the 50s up to about 80 odd rupees per liter. And it is not a regular signal. I don't see a constant straight line or a sinusoidal wave or anything like this. Now, first of all, getting a data set like this is not easy. This particular data was not readily available. There was a website which recorded the price of petrol in Bangalore every 15 days. So we had to look at the website and then scrape the data, screen scraping from that particular website to get this data. So data itself is very simple. There is a y-axis which shows the price per liter of petrol. X-axis shows time in dates or months. So what can we observe from this, right? So first of all, we see that the price of petrol is never below 50 rupees, never above 90 rupees. So it is what they call range bound. It has varied only within that range, right? And if we were to look at the overall shape of this curve here, is the price of petrol decreasing or increasing in this period? Right, that's very hard to say. Right, why do we care about that? Right, so we're probably trying to make a prediction of some kind. I want to know what will be the price of petrol in 2021. Now, using this past data, can I make a prediction and say this will be the price of petrol? One way to do that is to do regression. That is, draw a straight line, fit a line to this data set, then project that line and simply use that line to predict the future price for whatever date. So you take a point on the x-axis and then you project using the straight line that you fitted into this. Also, we have to consider some knowledge of the domain here. If I am trying to predict the price of petrol, say in December 2020 or March 2021, do I need to really look at the price of petrol in 2015? Is all of the historical data relevant, or should I cut this off and take a slice of data of the recent past? So these are all important decisions when we do analytics with time series data, right? So we'll get into some of those as we look at other data sets. Another example is the stock exchange data. So this I downloaded from the BSE, the Bombay Stock Exchange. They have something called the Sensex index. So this index actually shows the price of 30 of the most leading companies in India on any particular day. So the data set is available. The Sensex is one number and it is published for every day. And so it's the closing price on each day. And this is how Sensex has changed over time from about 1984 to the present times. So we are seeing an enormous increase, and there have been some major drops, major falls, major crashes in the market as well. Some of them were due to scams, and currently it is because of the COVID-19 coronavirus. So there can be any number of factors. So even in the previous example, the reasons or the causes for the change in petrol price are too many and beyond the expertise of a data analyst, right? It can be due to politics, geopolitics, a war somewhere, or some other exchange rate fluctuation. It can be due to pirates in Ethiopia. It can be any reason, right? So we can't really predict why it is happening. The causal modeling is not we are looking at. Whereas, as in all cases of data analytics, we are only trying to do prediction based on the data available. Now, in this case, you will see that it has increased from 0 to about 30,000, right? In fact, it went up to 40,000 and currently it has fallen quite a bit from that. Now, if this is the case, then how can we make a prediction for the future? Is it really possible to predict the stock market? For example, no one could have predicted the current crash that is happening because of the coronavirus, right? This was a factor completely unrelated to the stock market in some sense. But there's something else that is curious here. If you look at the first, say, 10 years, right, from 1984 to 1994, there was hardly any increase. It's all flat, right? Does it mean people were not making any money at all in the stock market in that decade, in those times? And if that is so, were they all fools? Why were they investing in the stock market? Right? So one of the things that anyway we have to keep on reminding ourselves is that the way the data is presented to us, the way the graph is rendered, can be very misleading. In fact, it so happens that Sensex started at 100 and it has increased to about 1000 but in the first 10 years, because you see the scale on the y-axis, it is 0 to 10,000, then 20,000, then 30,000. So an increase from 100 to 1000 is a tenfold increase, 10x increase in 10 years. That is a phenomenal increase. Anyone would have been very happy to invest their money in the stock market and get a 10x return in 10 years, right? So it just looks like it is flat here because of the scale on the y-axis, right? If you were to plot this data only for those 10 years, you would actually see a much steeper gradient or slope in the way the stock market changed in those days. Right? Now, if you take some other data from the stock market, right, there is another index called the Sensex Small Cap. This is for the Sensex index is for the large companies, what is called large cap, companies having a large market capital, whereas this is for the smaller companies, small cap. Now, if you see this data has been available from 2003 or so. So again, if you plot this, you will see that, right, the shape is somewhat similar to the previous one, but maybe it looks like there is greater change, more variation in the data, right? The statistical properties of this data set may not be the same as the Sensex. So there are terms like volatility that are applied to financial data. So if this is more volatile, that means it is less easy to predict its future values. If lesser the volatility, more predictable the data is when it comes to forecasting.